So last time, we talked about writing a sine or cosine equation from a graph. So here's a graph.
Indeed.
So let's start doing that. You guys can start on your own. I'll periodically kind of write in some stuffs so you can kind of self-check as we go. To get everybody started, what's the first things that we want to do?
Find the period.
So we want to identify the three key features, the midline, the period, and the amplitude. We'll use those to pull values for A, C, H, and K to build our equation out. So you try to write an equation for both sine and cosine. And I'll kind of, as we get going, fill in some information, kind of talk. So again, try to start on your own. As you're going, I'll be filling in some information and kind of talking through what I did to get that. Of those key features, which is the easiest one to spot first?
The
I would say the midline is the easiest one to spot. So why don't you start there by trying to identify the midline and figuring out what value A, C, or H, or K that is related to. Okay? Again, this feels like the kind of question that might come up on, say, like a homework quiz at some point in the near future, or like a test question. So like it's some pretty good practice right now.
Can I just like take a picture of it and then come back and see, because I can't really see it.
This is also the OneNote. So this is the page dated 9/23/25 or whatever.
Thank you.
To answer the question before, Joe, I would say yes, except like it's already at your desk or your kind of thing, you know what I mean?
Yeah.
Perfectly reasonable request if it wasn't like already there for you.
Yeah,
You know what I mean?
Hey.
I'm
okay, how are you?
So like the ending of it. Whenever. About like oh, okay, I see what you're saying.
So we start by identifying the midline. That's going to divide the graph into equal parts above and below the midline. So just using your eyes, it should be easy to see that the midline there is the x-axis. That's the equation y equals 0, which tells me the k value is 0. Next thing you'd want to search for is the amplitude, which is related to which coefficient? A, C, or H? A.
Siri, go on.
Siri, shut up.
No one's listening to us. There's something there to be.
Stop spying on me.
Do my Alexa.
So I'll let you guys think on that for a minute before we put something else on. Again, we should be trying to like focus on what's going on here. If you gotta look stuff up out of your notes for examples, that's fine. If you need to flip back and forth, that's fine. That's good practice. Yes, Ian?
I have a question with
Probably not, but it should be there.
I just want to
Probably not, unless there's like, you got this,
Oh, yeah. you-
that's like a totally different story.
Yeah, I'm talking about that last one.
The one at the end is probably not an update.
The other one, there's plus or minus.
No, but if the absolute value, basically that's what it's
It's plus or minus.
Three. Yeah, I know how to find it without three.
So does plus or minus.
Like, you don't have to make a speak while you see.
But how do you draw
Well, it's plus, it's minus one.
midline doesn't make any sense.
Wait, how do we find the frequency?
We don't need it.
Midline.
The frequency is the reciprocal to the period,
Okay.
so you wouldn't find it by looking at the graph. That's totally impractical. I mean, you can do it, it just, it
But
won't,
wouldn't it be
you know?
0?
Right, so once you found the amplitude, that's just the distance from a high or low point on the graph to that midline. So that distance is 3 units. So the A is the absolute value, or the amplitude is the absolute value of A. A could have been either +3 or -3, we don't know yet which one. We'll decide that later. What do we look for after the midline and the amplitude? Period. And what's the period again?
2 pi.
Well, it's the longest non-repeating segment of the graph, right?
Yeah.
So there's a couple of different places you could look for as far as your landmarks go to identify that, but I think there's a by far easiest one. And the formula for the period is equal to 2 pi absolute value c. That's correct.
Are we solving for sine or cosine?
Write both, write an answer for both. Yes, sir. So for sine, you're gonna choose a point to use the tiny-h, and the kind of point you want to use for a sine equation are the midline points. So you can pick any midline point. Well, no, it has to be where the graph is.
Oh, so I have to write it there. Okay. Oh, okay. And I just pick whatever
And depending on which type of midline point you pick, will just tell you whether you want the positive A. And for cosine, you're doing infinite axis. So you can find the period. That looks like.
Because it starts on this.
So it looks like you started was here, and then 4 1/4 there.
Like where do you get that?
7
Okay.
Makes sense.
Yeah.
So your period.
So it's just those two actual values and together.
I would think about it as like counting distance.
Oh,
You might actually simply went
Yeah, we're going.
3.75 to there, and you went 4 1/4 to there. I think that's a better way of thinking about it.
Yeah.
Less likely to make a sign.
Thank you.
So if you're counting your period, on this graph, it makes the most sense to count, I think, from max to max. So that period is the horizontal distance, so it starts here at negative 3.75 pi and ends here at positive 4.25 pi. So we're going to go 3.75 and then 4.25, right, if we're just counting. 3.75 to 0, and then 4.25 to the end. So that's 8 pi total.
And that's our period.
That's my period.
It's your.
See, that makes a lot more
We know that one period is 2 pi times absolute value c. So if I divide both sides by 2 pi and solve, I get c is plus or minus 4. But we're always going to just choose c to be positive. You can write an answer with negative c, but it's never going to be easier than choosing it to be positive. So let's just deal with one less negative sign, you know what I'm saying?
Wait, is that absolute value of?
Yeah. Absolute value c that I wrote? Yes.
So, where do we put the 8 in the equation?
What's that?
Where do we put the 8 in the equation? Because the period is 8 pi. not
So 8 pi
4.
equals
8
2 pi absolute value c. And then I just solve
Isn't the period still 8 pi now?
it. Yes, which is equal to
C is.
the equation 2 pi absolute value c.
Yeah.
And then when I solve that equation for c, I get plus or minus 4. Now I'm choosing to do the positive.
So when plugging it in, you would put it in 1 over 4 because no, it makes the most.
So when I'm writing my equation, I'm using 1 over 4 times. Yes.
The guy who trades. Yeah, he looks like EGR.
So everything we've done to this point applies to both our equation for sine and our equation for cosine. These first 3 steps are identical regardless of the type of equation we're writing. The part that's going to be different is figuring out the h and figuring out the sine for a. So when I'm doing a sine equation, to figure out the h, I need to choose a point to use. What kind of point do we want to use for writing a sine equation? We want a midline point. So I need a point where the graph crosses the midline. So there's 2 options here. Either one will be fine to use in your answer. This first option has the x-coordinate negative 7 pi over 4. This other one has positive 9. Oh my God, stop. Nobody wants to move this thing ever. 9 pi over 4. So this tells me that my h is everybody's okay? The x-coordinate just gives me my h. Because this is the going down one, this tells me that the a value, if I use that h, should be negative. Because this is the going up kind, that would tell me the A value, if I use that point, is positive. Does it matter which point I use? No, they both would give you correct answers. So we could have written this as y equals -3 sine of 1/4 x minus a -7 pi over 4 plus 0. One more. Or you could have written y equals +3 sine of 1/4 x minus 9 pi over 4 plus 0. So either one of those two answers would be appropriate. Are you okay there? Now to do the cosine equation, instead of using midline points, what kind of points do we use for a cosine equation? We use the minimums and maximums. So there's 3 options here, right? So I could have used this point. Um, 3.75 is 15 pi over 4. So the h there would be, and because it's a maximum, the a I'd pick would be positive. Here's a minimum, this is positive pi over 4. Because it's a minimum, that would tell me the a would need to be negative. And this one over here is a maximum at 17 pi over 4. So again, the h would be 17 pi over 4, and the a would be positive because we're at a maximum. I guess I didn't write the h here.
Mr. Smith,
Yes,
sorry, can we go back? How did you get that 15 over 4 again?
I rewrote negative 3.75 as a fraction.
Negative, what?
So this is the negative 3.75 pi, because it's the tick mark in between -4 and -3.5.
Okay, yeah.
So I just rewrote that as a fraction. So like -3 and, which means plus, -3/4. So like -12 over 4 plus -3 over 4. So like -15 over 4. Just making a mixed number into a fraction, or taking a decimal and converting it to a fraction.
Maybe.
3.75 is -3 and then 3/4, right?
Okay,
0.75 is 3/4,
yeah.
right? Like 75 cents is 3/4. And means add. To add fractions, you need a common denominator. So I took like 3 over 1 and multiplied it by 4 over 4. That gives me the -12 over 4. To add fractions, you just add the numerators and the denominator stays the same.
Yeah.
So there's my 15 over 4.
But like, what is the point of turning into a fraction? Do you just do it because?
It's the convention.
Okay.
It's the proper way of doing it.
Okay.
We write with fractions when we deal with radian values. That's what these pies are, or radian angle measures. We typically want to write those with fractions.
Okay.
So I have 3 sets of answers here that I could list. All of them are correct, or all of them can be correct. What was that one? 19, I think? 17.
Yes.
Now, on a test or quiz, would you have to report all the possible answers?
Yeah, well, if it says,
Yeah, but I won't. I won't ask for all the possibles. I'll ask for one sine or one cosine or one of each. I would not ask for all of them. That's just rude. You got better things to do than that.
Is that first, just the first equation? I want to say 6 or 0.
That first
Is there
equation.
For the cosine and then the bottom right. So that's 6 or 0.
Oh, the pluses are all plus zeros at the end. You're talking about that? Alex?
What?
Talking about that? Yeah, they're all plus zero at the end. Yes.
Would we have to put +0 or?
If you didn't put it, it would be fine.
Okay.
If there's, because anything plus zero is just the thing. I'm writing it in there so you can see like that I put the k equals
Got it.
at the end. Since if you're looking at this to like study from or as notes, I want to leave as like complete of an answer as I can for you so it's easy for you to tell what I did.
I got it.
But in general, like if you simplify this further, if you like distribute through the thing inside the parentheses or like you add the 0 at the end, like you take it further, that's fine.
Okay.
Not wrong. So this kind of a question, how many points do you suppose this thing's gonna be worth?
6, 7.
10, 6, 7.
Well, there's a minimum 4, right? One for the value for A, C, H, and K. And then probably another for choosing the correct sign for A. That's like a separate thing. Right, because you always have the option of positive or negative A, so that's like another point that you've done correctly. And then probably a 6 point for putting the whole thing together in the equation, getting the letters in the right spot. So probably a 6 pointer.
6.
I know. I don't even understand what that means, but okay.
it's like doodle.
Yeah. Yeah. All right. So let's push on here for today. So today we're going to be talking about graphing. So this is going to be the idea, the goal for today, the skill we want to walk away with is the ability to take an equation, a sine or cosine equation, and generate a graph from it. Everybody's okay with that? Yeah. So remember, what we're doing here is like, this is just a transform, any of these trig functions are just like a transformation of a parent function, right? So these A, C, H, and K change the way the graph is going to look. So the way we're going to do this is we're going to take some key points from our parent function for sine and cosine and transform them using this map.
Could you zoom in on that?
This.
Yeah, thank you.
To get our new points. So this guy, you're going to use all the time. That should be something we want to have memorized, or at minimum go on to the note card. The key points for sine and cosine. You'll use them to do the homework. You don't need to put them on your note card. You don't need to memorize them. I'll give them to you on a test or quiz, and I'll show you exactly the format that I would give you a graph, what a graphing problem would look like on a test or quiz. Okay, in terms of like what I would need for you guys to be able to, or how I would ask you to fill it in. I'll scaffold it a little bit so it's easy for you guys to kind of fill in some blanks for me. So this is the idea. So what I'm going to be doing is I'm going to, depending on whether it's a sine or cosine graph or function, I'm going to pull my values for a, c, h, and k to fill them into this thing. And then I'll push through the key points into this equation to spit out my new points, and then I'll plot those and kind of go on about my business. So let's start with this guy as our first example. So we're going to graph y equals 2 sine of 1/2 x minus 1. Scroll that up. First thing we need to do before we start is identify our values for a, c, h, and k. You okay, Tessa?
Yeah.
Okay. You need to just go and get a drink or whatever. Go ahead and do that. You have something. What's the value for a? 2. How'd you get it?
For the sine.
Yeah, it's the coefficient in front, right? So again, we're using just our general form to kind of read off the values. What's the value for k? That's the next easiest one to get. Minus 1, right? We can just tell because it's the number at the end. Those are the easiest 2 to get. C is the next easiest. What's C going to be? 2. Remember, it's always the reciprocal on that leading coefficient. And the h in this case, Frankie?
0.
0 is correct. Why is it 0?
So like when you factor it, it's like.
Yeah, you don't see anything added or subtracted to the x, do you? And it's 0, right? There's nothing there. We must have been adding or subtracting 0. That'll do. Are we okay with pulling those values for a, c, h, and k? Critically important that we're able to, that we possess this skill, because if we don't, guess what's going to happen? Everything afterwards is going to be wrong, right? Everybody's okay? All right. So using this, I'm going to write my map that says Cx plus h, ay plus k. And that's my transformation map I'm going to use. So if I start with a point from our parent function, I'm going to end up with a point in my transform function after I do that arithmetic to the coordinates, right? So this was a sine graph. So I'm going to go up to that table that I'd written above and write down the key points for sine. So these are the points from our parent function that we're going to be transforming. Do you need to memorize these? No, these would be given to you, right? So what I'll do now is I'm just going to take my points one at a time and plug them into this map that I just made. So 2 times 0 plus 0, 0. 2 times 0 minus 1, minus 1. And I'm just going to kind of continue doing that. Just plugging the x coordinate into the x spot. Plug the y coordinate into the y spot. And then simplify. So I'm just doing some arithmetic here in my head, right? 2 times pi over 2 is pi, and then plus 0 is still pi. 2 times 1 is 2, and then minus 1 is 1, right? Is everybody okay? You can always arithmetic it in your head if you need, or in your calculator if you need to. And I'm just going to crank through these last 3 points here. Those will be my new points that I'm going to graph. Are going to be 0, negative 1, pi, comma 1, 2 pi, comma negative 1, 3 pi, comma negative 3, and 4 pi, comma negative 1. If I look at my x coordinates here, do you guys see a pattern on how the x coordinates are changing?
Yeah.
What's the pattern? They're just going up by the same amount each time, in this case a pi. That'll always happen. Now it won't always be pi. But the difference between those x coordinates should always be the same amount. Whether it's a pi, or a pi over 2, or a 3 pi over 4, or whatever it is, the change of those x coordinates will always be the same. And look at the y coordinates here for a moment. How many units are there between negative 1 and 1? 2. How about between 1 and negative 1? 2 units. How about between negative 1 and negative 3? 2 units. Between negative 3 and negative 1? 2 units. So this should also always be the same, right? So those y coordinates should always be changing by the same amount. And coincidentally, what they're changing by is your A, well, or I should say, absolute value A. Yes. So when you're done, as you're going and computing these points, should you be checking after each one to make sure that, like, what's going on is actually what's happening?
Yeah.
Yes. It's the easiest way to catch an arithmetic error you know, there's gonna be fractions here that you're gonna have to add and subtract. Hold on. So like, this becomes pretty important way of checking to make sure your fraction arithmetic is on point, right? All right. Now that I have these points, I'm gonna now go and plot them. Everybody good with the plan? So zoom in a little bit. So I have 1 or 0, -1 is my first point. Then I had pi +1. Then we had 2 pi -1. And then 3 pi -3. And then we had 4 pi -1 again. Does everybody feel okay with what I plotted there? Oops. So if I connect them, I get something like this. Notice that I tried to draw a smooth curve here. It's not like pointy. It's not like straight line, straight line, straight line. I don't want to see that. I want to see a smooth curve when you draw it. Will I be picky about that? Yup. So it has to look smooth and curved, not pointy. Like straight and pointy is bad. Smooth and curved, good. And I'm also going to ask that you fill all the space on your that's provided here. So I want to extend this graph to fill up, you know, my space over here and my space over here. Everybody okay with that idea? To do that, though, I'm not going to compute new points. I'm just going to follow the pattern. So after the midline, I should be up at a maximum. So I should be going 1 pi over and then up 2 units to here. And if I go backwards, so this is now the end, should have come from a minimum. So I'll go 1 pi over to the left and then 2 units down. And then I go back to the midline. So I'm going to go 1 pi over and then 2 units up. And then from the midline, I go back to a maximum. So I'm going 1 pi over and 2 units up. And then I go from the maximum back to the midline. Oops. So 1 pi over, 2 units down. And then we're back here again, so back to the minimum. So 1 pi over, 2 units down. So I'm just kind of following that pattern again to fill the space, right? Did I do any extra computation here? No, I'm just counting, right? Doing the same pattern, just following the same pattern of up and down, up and down, up and down. The same amount over, the same amount up and down. Just kind of completing the pattern to fill the space that's left. Still okay? Okay. Let's do another. Yes, sir. Sure. Oh dear, my pencil. No, that's a long way down. So, on on your quiz or test, if I ask you to do this, this is the way that I would format your test or your quiz or test question. Okay? No, don't do that. Just give me this one thing. I just want you. Okay, thank you. There. Kept trying to take all my other stuff with it. Just want to move you. So this would be like the format of what you would look at, where you're going to fill in some blanks, right? Notice the key points are given to you here, the format for your map. So you're just going to kind of fill in your values for A, C, H, and K, fill them in here, show the work that you're getting, you know, the simplified point that you're going to be plotting, and then a space to do the plot. So we're going to kind of simulate that. Frankie? Sure. Does that feel okay? So when you look at your test or quiz question, you see all these blanks. We're going to go through and practice like what goes where. Everybody good?
Yeah.
Okay. So again, doing it this way should make things mostly just like plug it into the formula, get an answer, do your plotting, and be done with it, right? There's not a whole lot of like, I saw that to do. All right, who can tell me the value for A? 2 is correct. The next easy one is the K. Annabelle, what's that?
1.
1. Great. Then we look for C. What's that, Isaac?
1.
Not 1. It's related to the coefficient on the x.
Isn't it like the lower one?
Well, it's,
The fractions.
yeah, so you're going to use the reciprocal of that coefficient on the x.
So 2.
1/2,
Alright.
right? The reciprocal means taking 2/1 and flipping it. Does that make sense?
Yep.
Okay, so that's always the case. Everybody's good so far? Remember doing this? Adriana, how do we find the H? I've asked you 3 days in a row. I'm hoping that you're gonna, this is the one question I know how to answer because he's asked me so many times. Okay, so what do we need to do? We need to factor the stuff inside, right? What do we need? What number needs to get factored off, Adriana? The 2, the coefficient on the x. When we factor off the operation we're doing to the stuff inside the parentheses is division. 2x divided by 2 is just the x. And what is pi over 2 divided by 2 going to be? It's pi over 4, because remember, to divide fractions, we multiply by the reciprocal. So it should be pi over 4 for my h. I will promise you right now, there will be a quiz or test question where you have to be able to do this to get the correct value for h. Okay? I'll warn you right now, so if this is something you struggle with, like find some homework practice and like really bear down on those and put yourself some like time under tension and work through it enough times to where it's like, okay, you got it. And maybe also include that example then on your note card, right? If that's something you're going to struggle with, it like, Ms. Kulik, I know that's hard for me, then make it part of your note. Give yourself an example of how to do it again, right? And maybe not just the numbers, but like give yourself some words about like what you have to do. Write yourself a procedure so that when it comes to the test, it's like, this is something that'll be really useful to me. Not just can I look at and figure out like what Mr. Kulik did, because it's his work, but rather make it your work and your instructions that'll help you in the voice that you know you understand, not the voice that I'm going to give you. Do you know what I'm saying?
Yeah.
Okay. So from here, where does the C go? It's in front of the X. Where does the A go?
Oh, before the Y.
In front of the Y. Where does the H go?
After the X.
After the X. And where does the K go?
After the Y.
After the Y. Now this, not much different to write there, right? Since there is no like plus zeros or anything like to make it, or minus, plus minuses to make it easier, but everybody's good with how we filled this in? Okay. So now we would write in this spot, this is the spot to like show our work. All we're doing is plugging the 0 in for the X, and then the 1 in for the Y. Just a spot to show our work, to show Mr. Kulik, yep, I know where to plug this stuff in at. And then just a spot for our simplified result. So doing 1/2 times 0 plus pi over 4, 2 times 1 plus 1.
On a test would be laid out like minus all the green would be laid out exactly like this, where you're like, okay.
Yeah, where you're just going to be filling in some blanks for what goes where to put your work, where to do the simplified. This is what we're simulating right now, is how I would ask this question on a test.
How many types of these questions?
On a test, I would think at most 3.
Okay.
Not a lot.
Okay.
It's rather time consuming what we're doing right
Yeah.
here in the time setting.
Yeah.
Like all the questions in this chapter are rather time consuming, right? Even the one that we did at the start here, even when you're fast at that, it's still like, it's a solid like 3-4 minute question when you're aces at it, where it's probably more like a 5 or 10 minute question if you're like, I mostly know what's going on, but like I have to be slow and careful here. And it's like worse than that if you're like, I don't know what's going on. Or maybe it's faster because you don't know what they have anything to do anyway. Anyway, I'm going to continue kind of grind. Stay. Okay. All right. Let's continue kind of grinding our way, plugging things through. Now, as you're doing this, if the fraction arithmetic, like doing 1/2 times pi over 4 plus pi over 4, if that looks daunting to you, What can you do to make your life easier? You can do that arithmetic on your calculator if you remove the pi's. So if you just do 1/2 times 1/4 plus 1/4, your calculator is going to spit out 3/8, and you just put a pi on the top. Everybody okay? So again, we've talked about how to do that. Previously, oh my gosh, guys. Do you see a mistake with this last one? Yeah. Phew. Okay. Before I got too much further, I caught it. I'm like, wait a minute, these aren't going to follow the pattern. Where's my mistake? It's like, oh, it's the dumbest possible mistake. It's the transcription error. Does everybody feel okay with what we did here? Like the format of how I'm going to present this to you on a test or quiz? I think this is helpful because it really organizes it for you, forces you like, this is the steps. Like, you got to fill this out, and then you fill this out, and then you fill this out. You get these values, and then this is what we're plotting.
And then is there supposed to be a pattern for the first one?
Yes! Do you see the pattern?
Pi?
So the pattern is everything is going up by a quarter, right? 1/2 is like 2/4. 1/2 is like 4/4. So if you look at the x's, everything is going up by 1/4. You see that now? We had 1/4, 2/4, 3/4, 4/4, 5/4. So yes, there should be a pattern with the x's, and that is the pattern that we should notice.
Okay.
Right? Do the y's all check out? The difference between the y's at every step is 2, right? From 3 to 1 is 2 units. From 1 to -1 is 2 units. From -1 back to 1 is 2 units. From 1 to 3 is 2 units.
Okay.
So that's our check at the end, once we've pushed all this stuff through. So far, so good? Okay, let's do some plotting. So we have pi over 4 and then 3. Go ahead. And then 1/2 and 1. And then 3/4 and -1. And then pi in positive 1, and then 5 pi over 4 and 3. Is everybody okay with what we've drawn so far? I'm going to scroll this up now. So that's my initial, right? And then I just need to repeat my pattern. So I'm going midline, minimum, midline, maximum, midline, minimum, midline, maximum. And I'm going to trace this over, and it's like super annoying because there's like a million points to plot. Just kind of going over and then up or down 3, over 1 unit and then up or down 3 units. Just kind of following the pattern that I'm seeing. And we do the same thing over here. Oops. Oh my goodness, I goofed something up here. Where did I go? This guy's in the wrong spot. Yikes. I don't know, whatever it is, it's embarrassing though. Don't you hate it when the autoplay gets you in the middle of class? Could have been the tablet too. Those guys get you too. It's like I wasn't watching YouTube during the lesson. Or looking at TikToks or Instagrams or, you know. But there you go. How many points do you think a question like this is going to be?
A lot.
It's probably like a 9-point question. Like one value for 1 point for the A, C, H, and K. You know, like 1 point each for probably generating the correct points. And then probably 2 points for plotting and extending. I think that comes out to be 9, I think, or there-ish. Yeah, Alex?
So when we're extending, can we either do that or color, or like color it in, or we can only like just do that?
So I wanted to see like the points that you put to extend it, and then just, it doesn't have to be different colors to do the extension. I was just kind of, on the first example, showing you what we did initially and then where the extension comes in. When you're doing it in person, like one color is fine. You don't need multiple colors by any means. Does that make sense?
Yeah.
That's what you're asking, right? Ellie? Absolutely. All right, you guys, guess what time it is? Time, well, I mean, yeah, but time to try one on your own. If okay.
Yeah, I know that.
Okay.
So I'll do the same kind of thing we did last time when we did this at the start. So here's your problem. You guys should start on your own. Periodically, I'll come in and like start writing in the steps behind you, give you a little bit of a head start here, but never really let you get so far ahead that like you screwed something up big time that, you know, you did the whole thing wrong before you found out. Does that sound good to everybody?
Sounds great.
Okay, so again, try this on your own. I'll kind of start filling stuff in behind you here pretty quick. You know, look at the previous example if you need to.
This is the tab after the date. Yeah. Does it? Yeah. Yes, it is. Bro.
So, stop right.
Can you do H on the board? Or how to find H?
So,
It's sorry.
Two x divided by two x. And then if I take this guy, I divide by 2.
Okay.
It's the same as multiply by this one.
Okay.
Multiply straight across.
And then it would just be 3 pi over 8.
It should be negative.
Oh. How would you know that it's negative?
So, the general form
Oh, is this being negative? Is it in the formula?
yeah,
Okay.
well, it's minus AC.
Okay.
So the H is always, this thing is always the opposite side, what it looks like there.
Right now, what's it tell me right now?
A equals 3, C equals 1 F. H equals 3 pi over 8.
Negative.
Oh, yeah. Hey, negative.
H equals
What
what?
was it negative?
H equals 3 pi
So, in
over
the general form, it's x minus h.
Oh.
So H is always like the opposite side.
And then your K is just
Again,
I don't mind.
Yeah.
like again, that's something I've done, like know myself.
the x, y. The x, y, and the 0, 1.
Are we doing?
Yeah, we are good.
But we're doing all the examples.
They can understand.
No.
Yeah, you're doing the whole thing, you're graphing.
Every 5 weeks.
Wouldn't it be 0, 1?
It's sine, not cosine. So, for different sets of key points.
Okay.
So when it was cosine,
It was
it's 0, 1, but
Well, senior side, you're under here.
when it was sine,
So senior side, you're under Caesar.
Oh, cosine.
Rolling, bro.
It's not even his fault though.
Let's just do the same, but sine is 0, 0 and cosine is 0, 1.
They're kind of stable in both of their blood.
It's there.
Okay.
Yeah.
Oh, and then this makes it 0. Okay, sure. Yeah.
I got 300 pounds and like.
Can you give us that table?
I would, well, when you're graphing, like, you'll have this
Okay.
along the side, so you don't even need the table.
Okay.
Like, it'll be set up for you where they're already there.
What's that?
He does that. Yes, 8 yards.
Yo, who said that?
No, he didn't. I swear. That's ridiculous.
Derrick Henry got that one touchdown at 11.
Oh, yeah, it's not unfair. It's not like he did it on purpose.
Derrick Henry.
He definitely fell on you on purpose, but he didn't break it on purpose. Yeah, and if he broke it on purpose, he would have grabbed your thumb and just snapped.
That's what I'm saying.
You know,
I didn't play football for the last year and a half.
So, you know, the last one, we did 0, like, 0, 1.
What is this?
On this one, we're doing 0, 0.
This is crazy.
Oh,
This is in different settings with ones to start.
Wait, you stop. I'm not talking about him.
No, he did. There's so many side effects. What do you think? What?
You finish it that fast,
Mr. Floyd? Mr. Floyd.
Like,
He's been doing it for how many years?
like 20 years or something. I've been being a manager. So imagine, one, you live in a world where like, math kings,
Yeah.
and then you did the same class for 20 years in a row.
Oh, yeah.
Like how good could you be at that?
I just so.
It's like how good Jacob is at Clash of Clans.
Yeah.
Fortnite.
Yeah.
It's like you've been doing it your whole life.
No, Jake is so
And
good.
you were so good to, you're like, I'm good to start, and then I just dumped all of my free time into doing it.
It's actually so impressive when Jake plays for it.
Yeah,
It's something else.
right, it's just like how Mr. Gordon can just walk up there and it takes 10 seconds to do a problem like this. Like all in my head, don't have to write anything down.
Yeah, it's pretty ridiculous.
That's what you have to look forward to after 20 years.
Yeah, I don't think I'm gonna be in the math force.
You know?
You never know.
You never know.
Minus 3 pi over 8 for every school.
3 pi over 8 is pi over 8. I feel like free calc is the
Yo, I was the first one to write.
Free calc means
I know, the first.
So it's 1/2 times
and then you
then minus the 3 pi over it.
Okay, so
I'm writing it down, okay.
it's literally like
That looks fine.
That's all.
Yeah.
Yo, do you want one?
Yeah.
Do you want one? I'm going.
It backwards to backwards to climb because it's fraudulent. How much did it cost?
I sent you a new card. You should have Nah, it took me like like 2 weeks. Well, like you can put on Apple Pay right away. No, like, I got it on Apple Pay.
Oh, yeah, I'm doing that.
And you have to give like a makeup. Oh, did you buy makeup? Makeup? I think you're
I
I don't know. You can verify you can get it back. Like you can get like a new one. Like a new card on Apple Pay right away. I know about it. Why are you asking if I'm sad? Yes. Yeah, no.
Yeah. I think so.
I'm not
No.
Let me tell you, I'm on bag 18, chippy. Oh my god.
So maybe he's gonna play.
You're gonna be in the negative.
I hope he doesn't put this.
Hey, do it.
It's like you.
I did like 31.
Oh, he's also.
Yeah, then John knocked.
Wait, Elliot.
This is what I was gonna.
Yeah.
Everyone
It is when you go right. You want to DC the coach.
I just jumped like you. This something just happened to be
I'm going right here.
Call me crazy for you. No, that's like
I'm dying to go. I'm dying to go. Not me. I would never hear you. I'm dying to go. I'm dying to this guy saying I'm going to I'm dying to on the side. I'm dying to I hurry. What are you trying to say here, bro? No, bro. On the other side of the court. I'm laughing at you.
Yeah, but you did fall on your
I can't lie, I was so glad.
Where was he? I don't know how I got this. I wasn't even near you. I was on the court.
Yes.
I'm gonna stop here. This just got annoying. Just try to do this.
It's for the Ravens.
I got 8.